I have a very powerful but a simple question to ask you. All of you are healthcare practitioners. Have you ever thought that these days we are definitely seeing much more diabetes, much more cardiovascular diseases, much more cognitive decline, autoimmune conditions, much more chronic illnesses than ever before, despite having more diagnostics, more medications, and more technology. In fact, we are in the fastest time in history when we are doing all of this. Is it that we have actually become much more better in naming diseases? Let's think differently. We all are functional medicine practitioners, and of course, thinking differently is how we do things. What if all of these different diseases, different conditions, different names that we take are actually connected to a common biological thread? Yes, that common thread is what we're going to cover today in our topic, inflammaging. And by the way, before we get started, I want you to know a very, very inspiring story. And of course, there could have been no better guide than the speaker today for this particular journey. So, Dr. Harcharan Singh story I'm going to tell you about his story, is one of those many healthcare professionals that you can definitely relate to. So, after completing his medical school in India and internal medicine residency training in the United States, he spent more than 25 years caring for patients and educating the future healthcare professionals. But after decades in medicine, he began noticing something that deeply concerned him. You might have heard this saying, right? Uh, Please don't add years to your life if you don't have life in your years. Is that correct? That is what he started seeing in his patients. That, yeah, people are living longer. My patients are definitely living longer, but they are becoming sicker earlier. They are accumulating more and more diagnosis, more and more medications over time, and more chronic diseases over time. That question started clicking the speaker who is going to join us today. He thought, can we help people not just live longer, but actually stay healthier, stronger, sharper, and more vibrant, more vitality for the longer run? And I'm pretty sure all of you want this for your patients as well. We all want this. We just don't want to just get healed. We want a healthier, stronger, sharper, vital life with us. That's the question that led him to think beyond the conventional disease management. And he, of course, just like everyone else, he dug deep into the functional medicine domain, longevity science, metabolic health, health span optimization, and human performance. Today, through NELI, which is Nelly, the Nutrition Education for Lifelong Impact, he is helping educate practitioners and health professionals in the science of longevity and preventive healthcare. And through the LVC, which is the Longevity and Vitality Center, he is helping individuals apply these principles in the real world clinical scenario to improve health span, to increase, and of course, the quality of life. Now, he has a very simple belief. The future of healthcare is not merely just treating disease. After all of his decades of practice has taught him. It's not just treating disease, it's understanding and addressing the processes that simmer deep inside, that drive the disease in the first place. That is what brings us to this today's fascinating topic known as inflammaging. Inflammation plus aging, the vital link between aging, chronic disease, and longevity. So, how do we think? What if the inflammation which is driving diabetes is also contributing to that BP, to the high BP? What if the same processes are influencing the cognitive decline that you see in aging, the frailty, the loss of muscle mass, and all of that accelerated aging symptoms that we see? What if understanding this particular concept, this biological concept of inflammaging, could completely change how we think about prevention, chronic disease, and longevity? Well, it's going to be a very exciting session because these are the questions that we are going to explore today. And to make this session even more valuable, by the way, I want to inform you initially itself, Dr. Singh has generously prepared a practical clinical handout for all of you. This will be shared in the group after the session. Okay, so hold on. It will serve as a useful reference guide for all of you in your practice related to inflammaging. So, are you all ready? I would love to get some really good thumbs up over here. Please be liberal enough to use the react button just like I am doing. I would love to see all of this coming in generously in the webinar because get ready to connect a lot of dots that are there in your mind, challenge some assumptions that are also there in your mind, and perhaps see aging and chronic disease through an entirely new lens. So, please join me in giving a very, very warm welcome to our speaker who's joining from the US. So give me a minute to bring him on screen. By the way, I just wanted to add on Dr. Harcharan Singh doesn't like to be mentioned as a doctor. He loves to say, I am Coach Singh. Is it true, Dr. Harcharan? Really nice. Thank you so much for joining in. A very,
Yeah.
very warm Sat Sri Akal and a welcome to all of to
Sat Sri
you.
Akal. And Ms. Benz, by the way, I didn't know you know me so well. Okay. It was really nice. It was such an introduction. And I want to say greetings to all our listeners today because you got different time zones. So I want to say namaste, Sat Sri Akal, salam, whatever, but I also want to say good morning, evening. But, it's nice to be here. I want to thank you for inviting me. I think this is a topic I'm passionate about it, this thing. And, I really want to share my thoughts and what I've studied so far. And hopefully other practitioners can, get something out of it. And because it's always a learning curve, that we
Yes.
all learn. I know in India, in Rohtak Medical College, I was 17 and a half when I went to medical school, and I was underage actually. And from there, it just became a journey and ups and downs. And but on the other hand, I'm still standing and we're working. So we're learning every day. Okay.
A lot to learn
So
from you,
having said
sir.
that,
I'm
sure,
going to move away from the screen so that you
sure,
can share your screen and you can start the topic as well. Thank you
sure.
so much,
Sure.
Dr. Singh, and I shall be moving away. Thank you.
Thank you again, and welcome everyone again one more time for today's webinar, which is about inflammaging and longevity medicine. Today, we are going to discuss a major shift that's happening in the modern medicine and aging services, which is gerontology. The realization that the chronic low-grade inflammation may represent one of the most significant central biological driver of aging and chronic disease. And this is the topic we're going to talk in more detail today. This topic is more important today because clinicians, coaches, and other allied health professionals, all of us, we are really actually seeing patients now who are coming to us more. They're not acutely sick. We do not have the enough criteria to make a diagnosis with a traditional conventional medicine, but they have multitude of symptoms like fatigue, weight gain, cognitive decline, and are experiencing some metabolic dysfunction as per some labs, initial labs, and poor recovery and sleep disruption. Now, earlier we used to ignore that in practice and say, okay, watch your diet, do this. And now patients are learning a lot from AI. They are learning a lot from Google somewhere. And now they're asking us questions. Hey, what do I do? And they actually, people are, these days are looking for more vitality. They don't accept the fact I'm getting older, so I got to slow down. So we as practitioners, we have to have an answer. So that's why, I want to discuss this topic, how the biological link between the aging, chronic disease, and longevity medicine works. So welcome everyone. Let's get started. Let me get first started with the um, first. Let's just introduce. I belong to the company Nelly. Just a disclosure quickly. I think Dr. Dunn and Dr. Peterson are on there. Dr. Wen should be there. So we all here to talk about this. Our goal is again, I want to bring is provider-led coach implementation and data integration. I will discuss that later. But let's move on to the slide, which is right. We all know we are living longer now, but we're not necessarily healthier and not as vital as we want to be. Historically, medicine always created these things that they had. We always diagnosed diseases differently. Cardiovascular disease separately, done by cardiologists. Type 2 diabetes was with an endocrinologist. Alzheimer with neurologists. All these things. So now things are changing. People are looking at things a little bit different way. Now, just to let you know, the data from U.S. Census Bureau shows that about there are 50% increase in the centurion, people who are living longer than 100 between 2010 and 20, rising from 53,000 to 80,000 people. Rapid growth happening every year. And also, by the way, next 3 decades, this number is going to go from 100,000 in 2024 to 422,000 in 2054. Also, globally, this surge is happening, and they're expecting again from 24, people are 722,000 is going to go to about 4 million by 2054. So a lot of people living longer now. We got to make sure they are healthy also. Now, US and Japan and China are the top right now, and India is number four. Same way as an economy, India is number four. So, but also, by the way, they are saying by 2050, India is going to be number three, and most of the population will be in rural area. And Uttar Pradesh somehow is predicted to have the most people who are living more than 100. Having Okay, now this shift I'm talking about today is that we understand we always train this way, that conventional 20th century, that's how we train. And if you see in this thing, the slide, traditional medicine model says disease happens, then symptoms come in, and we diagnose disease from there. We have differential diagnosis, and we set up a treatment, and then person's, let's say hypertension, blood pressure goes up, we add second one, then we see the blood work to see, make sure the side effects happening. This is we are trained in all the time. That's the one. Now the new model that we talk longevity medicine is actually more biology central and prevention and system based. It treats a root cause, take whole body approach. Here we look at the biological dysfunction, the chronological, which is now we'll go over this in a minute with the chronic inflammation, how this plays a role in that, and how the system breakdown starts. And that's when the disease expressions happen. And this is where we come in. So, way before disease starts, this is where this longevity medicine goes in there. Let's talk about what is inflammaging. Inflammaging, as you know, is a chronic, sterile, low-grade systemic inflammation associated with aging. And we will go in detail, but this definition will come back to again. We all know the acute inflammation, which is short-lived, purposeful, and resolves completely. It's very protective and reparative. As a matter of fact, we really need acute inflammation for our survival. Now, inflammaging, on the other hand, it's a persistent subclinical event that keeps happening after the trigger is gone. So actually you don't see any identifiable trigger, but it fails to resolve. And this is the important part. Please remember, we're going to again discuss this fails to resolve, because acute inflammation should resolve in time, but it doesn't. So that fails to then now becomes a inflammaging. Now, why this even matters? Inflammaging is not merely a biomarker of aging. It is actually a driver of the biological age. This concept matters now because it affects metabolism, vascular health, cognition, muscle integrity, hormonal signaling, and immune resilience, and even the recovering capacity. This is why it is becoming more and more viewed as a central biological bridge between chronic disease and aging. Now, from a longevity medicine perspective, our goal is not simply to suppress the symptoms, it is to identify the inflammatory burden early, reduce chronological, changes, biological stress, and preserve physiological resilience over time. Again, we'll go over in detail why inflammation becomes chronic. We understand there are few triggers that don't let this inflammation subside, and most interesting part is that most of these triggers are modifiable. So that's where comes the concept of modern medicine or longevity medicine, where all these things will become important. Let's talk about what is inflammation. Inflammation is the body's fundamental protective response, like I said. There are cardinal signs which happen, like rubor, tumor, functional. We all learned in medical school, and later on, these become, there are some mediators that go with it called, the cytokines and prostaglandins. They will go with it, and then if you see that complements reactive oxygen, and we all actually measure these levels as it goes. Now, the key cells that goes behind the neutrophils, macrophages, all these are involved in the inflammation process. Now, it is now required, like it's essential for survival, but has to be properly regulated, inflammation. Now, let's see the process of acute inflammation. Acute inflammation as a body's first response. Injury happens, immune system is activated, our innate immune system, then repair happens, and then resolution happens. And that's where they come in resolution part. Let's discuss that in detail a little bit. Historically, scientists believe that inflammation fades passively when the protective job is finished as the biochemical triggers are diluted over time. Researchers now understand that the end of inflammation is an active, highly regulated countdown phase managed entirely by SPMs, which we'll discuss in a specialized pro-resolving mediators, which are lipoxins, resolvin, which is omega-6 and omega-3, and also which actually are required to get the tissue homeostasis back. Now, discovered by Dr. Charles Sirhan at Harvard University, this represents a monumental paradigm shift in the immunology method. The mechanism is that, by the way, people ask, okay, we can give anti-inflammatory, and but that's a suppression of inflammation. SPMs do not suppress; they just bring the tissue back to homeostasis. So, two totally different mechanisms. Now, their SPM, what they do is they will halt any new recruitment of the white blood cells. So PMNs, polymononuclear neutrophils will not be coming anymore. The macrophages, they will not start more activating, and only they will M1 to empty. They will go from M1, which is the initial part that causes damage, M2, which is the healing part. They will come more, and that will actually start clearing up the stuff. So these things start happening, and that's how this information becomes resolved over time through the SPNs. Now, the failure to resolve of the LMS with a lack of SPM activity becomes now chronic inflammation. Well, now, this is important part is the protection now becomes the pathology and could be causing acute chronic low-grade damage to the tissues. So this chronic inflammation actually is persistent, it's dysregulated, impaired resolution is often silent because there are no signs like pain, fever are visible, and tissue damage keeps happening. So but the problem is, here's the good part of this. In the slide, if you see, I've listed some major triggers that will make this happen, like chronic psychological stress. We all have that. Visceral obesity, which is doubled every year. Poor sleep pattern. Okay, the environmental toxins and gut dysbiosis and sedentary behavior. All these things actually contribute, so SPMs cannot carry out what they're supposed to do, and that's why inflammation can become chronic. Let's quickly talk about what is acute versus chronic inflammation is. We'll discuss like acute, which is rapid onset, has to be secondary to a trigger. It has symptoms, we talked about, and signs. It resolves completely with healing, and that's the purpose is reparative and protective. Now, on the other hand, and there are some cytokines released, different ones here. Chronic, on the other hand, is often no triggers, is subclinical, silent. Patients have symptoms, low-grade symptom, but they don't know. By the way, this is just want to mention people who had COVID. A lot of people we see in the practice who are actually they have chronic COVID, and that subclinical, silent, low-grade inflammation is going on. It just fails to resolve, and tissue damage keeps happening over time. But here there are different cytokines involved in this. And we'll discuss all the biomarkers, but this is what we're talking about acute versus chronic inflammation in general. Now, this is a very important slide, how we go from inflammation to inflammaging. If you further dissect this process, if you see here, where the failed resolution is secondary to impaired SPMs and ongoing DAMP symptoms. I'm going to explain what the DAMP is, okay? Now, our body system, innate immune system, relies on the pattern recognition receptors, also called PRRs, to detect any threats. The receptors, they pick up two distinct kind of signals, which is either PAMP or DAMP. DAMP is actually, PAMP is actually with pathogen associated molecular patterns. So any exogenous molecule comes like a viral RNA or a bacterial cell wall, liposaccharides, all these things come in and they cause a reaction. This is a alert from an infection. So those molecules released are called pathogen associated molecular patterns, which are PAMPs. Now, the other one's called DAMPs, which is damage associated molecular patterns. They are endogenous molecules released from our own cells, and they're released from damaged, stressed, dying, or necrotic host cells. Now, they act as internal smoke alarm in the immune system. While they function normally and safely inside a healthy cell, their presence in the extracellular space actually communicates tissue trauma, structural injury, metabolic stress to the body. So body has to react it. So DAMP are actually a response to injury or sterile stress, not to physical trauma. Now there's a trauma, burns, toxins, and oxygen deprivation. These are examples of the sterile stress, and it requires no infection trigger here. Now, common example of damp signals, like if I give you, like there's some extracellular ATP. If the cell membrane breaks down or loosens up from some inflammation, the ATP can leak out, which is actually our energy molecule, and then the body treats this as a trauma, and it starts actually working as a threat and starts producing inflammation against it. Same way, mitochondrial DNA. You all know our mitochondria actually initially evolved from ancient bacteria, and their DNA contains structural patterns resembling pathogens. So if the cell lyses or spills out somehow the mitochondrial DNA, there will be a reaction to it again, same way. Heat shock proteins and uric acid crystals are other examples of DAMP. The downstream effect here is that if you see it, the cell trauma, damp leakage, then PRR binding happens, inflammatory cytokines are released, and neutrophil recruitment happens. Inflammation keeps becoming chronic from there. Now, acute repair, if all this happens in a healthy setting, this is good. Dams are cleared and they by SPMs, and it is all goes back to normal. The healing happens, physical wound or clear dead tissue is all removed by macrophages. But if the underlying stressor does not stop due to metabolic disease or poor diet or chronic toxicity, now dams are continuously produced, and this triggers a runway positive feedback loop where progressive tissue damage constantly releases more dams, driving chronic inflammatory disease like rheumatoid arthritis, atherosclerosis, and gout. And we're going to discuss all these more in detail. Now, here's the one thing quickly I want to take message. This one here is, so we have a DAMP which act like as a paddle to drive the inflammation, and then there is a SPM which acts as a brake to the inflammation. And this balance sometimes gets bad, and that's how the problem comes in. Let's talk about historical evolution of inflammation. It's not a new concept. More than 2,000 years ago, Roman physician Celsus, he described about inflammation and described the four signs: redness, heat, swelling, and pain. Later on, Galen, he added loss of function as the fifth sign of the inflammation. At that time, inflammation was still recognized primarily as a protective healing response to injury or infection. Important thing is, the ancient physicians already understood inflammation was just part of body's attempt to defend and repair itself. However, inflammation was still just local and a visible process. There are signs and it's local, not systemic. Now, this is now not no sign of this thing that this could be a systemic process later on. Rudolf Virchow back in 1858, that's when he came, a German pathologist. He came in and he actually the first one who said that chronic inflammation played an important role in disease development, particularly atherosclerosis. His work was mostly about cardiovascular atherosclerosis disease, and that's how he came up with it. This was a revolutionary because medicine previously viewed chronic disease mainly as a mechanical and degenerative disorder. Now he said no, inflammation is the one causing me a problem here. Now cellular pathology is happening, and that's where inflammation comes. That's how symptom comes later on. Today we recognize that atherosclerosis not simply as a cholesterol accumulation, but also a chronic inflammatory vascular disease involving endothelial dysfunction, immune activation, cytokines, inflammatory plaque formation, and plaque vulnerability that causes plaque to rupture. So we know all this today. He said that is back in 1858. So Worker's idea laid the foundation for the modern medicine, understanding that chronic inflammation may contribute to many chronic diseases, and this was over a century ago. Now, silent chronic inflammation, let's talk about this is the invisible driver. Acute inflammation we talked about, there was all signs. Here it goes undetected, no pain, no fever, no signs. Standard labs often look normal or maybe mildly deranged. Symptom onset is decades downstream. There's no single trigger to identify, so we're just wondering what's happening. We sometimes give antidepressants, sometimes we call it, say you're going through menopause. We have so many patients we see, we tell them, oh, don't worry about it, just watch it, or just lose some weight, do some exercise, or eat better or something. We do not have a real answer to that. What's happening beneath the surface here is there's a persistent the cytokines going on. There's elevated interleukin 6 tumor necrosis alpha, endothelial dysfunction and plaque growth is happening, and progressive neuronal and beta cell stress is happening. That goes to diabetes or Alzheimer's, all these cardiovascular disease. It is all happening slowly or underneath the surface. Now, let's talk about obesity a minute, and we'll go from there. One of the most important discoveries in inflammation biology occurred when researchers realized that adipose tissue is not merely a passive storage organ. Actually, visceral fat is actually metabolically and immunologically active. Now, clearly, we know that adipose tissue, visceral adipose tissue, has 40% of the adipose stromal cell are inflammatory there, as compared to less than 10% in the lean individual. So we know there's much more inflammatory cells in there. Also, we also know that this led to the concept of inflammation from here. That we know that some key cytokines are released, and then the also third part is adiponectin suppression, which is anti-inflammatory. So three things are happening side by side within visceral tissue, which is causing obesity and metabolic inflammation. And all these three actually lead to more inflammation. A chronic inflammatory state driven by nutrient excess and metabolic overload. Therefore, obesity, insulin resistance, and metabolic syndrome were increasingly recognized as inflammatory conditions now. This dramatically changed how clinicians and researchers understood chronic disease development. What is neuroscience? Which is it's a scientific discipline that investigates or puts a relation between the fundamental mechanism biology of aging and pathogenesis of age-related chronic disease. This is an important concept to understand here that this neuroscience is the one base for how to go deeper into the studies of the chronic inflammation. The research now recognizes that aging is not simply a passage of time. They have defined, if you see here, Lopez, Oten, see this study, this article from 2013, they decide 12 hallmarks of aging processes, including cellular senescence, mitochondrial dysfunction, oxidative stress, immune dysregulation, gut microbiome, all these I've listed here. The modern field of neuroscience brought these ideas together into the concept now known as inflammaging. So, rephrasing what we talked in the beginning, inflammaging refers to chronic, sterile, low grade inflammation that develops progressively with aging and contributes to the age related diseases. So, it develops with the aging and contributes to the age related diseases. This concept has become central to longevity medicine now, modern medicine now, because it links aging biology directly to the chronic disease development and functional decline. And as we learned in the previous slides of neuroscience, the inflammation is not caused by a single pathway. It's actually network level biological disturbance involving multiple interconnected systems. So, multiple protective biological mechanisms that normally maintain survival and repair begin becoming dysregulated over time. And these mechanisms actually, like I talked earlier, like innate immune signaling, mitochondrial function, cellular repair system, gut barrier integrity, metabolic dysregulation, and immune resolution pathways. All these are working together to work on the inflammation part. The result is persistent low-grade inflammatory signal because they go out of order. Importantly, these mechanisms interact continuously with each other. Like example, mitochondrial dysfunction increases oxidative stress, which activates inflammasomes, and I'm going to go over that in a minute, which further stimulates immune signaling, which worsens metabolic dysfunction and cellular senescence. So this is the loop that's created, and that problem happens with chronic inflammation. It's a low-grade, persistent pathway that takes over. Now let's talk about our innate immune system, which gets overactivated here. Our innate immune system evolves as a rapid response defense system against any danger from outside. We talk about PANC and DAMP. Normally, innate immune activation is short-term and protective. However, in inflammaging, innate immune pathway becomes chronically overstimulated. Now, this the study here from the Nature Review Endocrinology 2018, it shows that three major categories of inflammatory triggers here. First, which is also called non-self. Like I told you about the PAMPs, we talk about the bacterial lipoprotein polysaccharides, viral nucleic acids, all these, they come and put a trigger there. Second is self-derived, which is endogenous from the body. They're called DAMPs. We talk about mitochondrial DNA and all that. The third one, this paper wrote, we call the quasi-self triggers, which are basically modified lipids, oxidized LDL, advanced glycation. And actually, this is where the main part comes in. Particularly like excess of the nutrients, metabolic overload, and gut-derived internal inflammatory molecules. All they come in this thing, uric acid crystals. All these metabolic overload is the one which can also drive the immune system overactivation. So either PAMP or DAMP, and the third one this paper wrote was quasi-self triggers, which are very important for this whole concept of imaging. Now, the body may respond to chronic metabolic access as if this is a persistent danger signal. And that's where the role comes in obesity and metabolic overload. The result now is ongoing and like tumor necrosis factor, interleukins, and other inflammatory mediators. Cellular senescence we talked about earlier. As cells age or experience repeated stress, some enter a state called cellular senescence, also known as zombie cells. These cells stop dividing, but they do not disappear. Instead, senescent cells remain metabolically active and begin releasing inflammatory signaling molecules known as SASP, which is also called senescence-associated secretory phenotype. This is important because this is a continuous insult that's happening to the cell. Now, they'll include cytokines, inflammatory mediators, tissue degrading enzymes, all is included in that. These are the components I've listed here for you. Now, while transient senescence can be protective, persistent senescent cell accumulation contributes to chronic inflammation and tissue dysfunction on an ongoing basis. One more important thing here, senescent cells can also spread inflammatory signals to the neighboring cells. They impair stem cell function and reduce the tissue repair capacity. This is one reason senescence has become a major target in longevity medicine and senolytic research, and we'll discuss that in a minute later on. Now, we talk about mitochondria, as we know, has two key roles in our body. One is energy production, and second is cellular resilience, how we recoup. As mitochondria become dysfunctional with aging and chronic stress, several things occur simultaneously. ATP production declines, okay? There's excess of ROS generation, reactive oxygen species, and then there's also the oxygen, so this causes oxidative damage. And then also there's damaged mitochondrial DNA we talked about, which is basically a dam. All these things start happening as we age. And so all these processes contributes to inflammation also. Mitochondrial dysfunction actually, if you see, becomes both a consequence and amplifier of inflammation because of these ongoing processes. We talked about inflammasome. I mentioned inflammasomes earlier, so let me talk about that. These are the intracellular inflammasomes are the intracellular danger sensing systems designed to detect stress and cellular injury. The best study system here is NLRP3 inflammasome, and I'll discuss that. It can be activated by oxidative stress, mitochondrial dysfunction, metabolic overload, crystal cell debris. All these things, or nutrient excess even. All these things are happening in the body as we talked before. Once primed and activated, okay, this causes cytokine release, like again interleukin 6 and interleukin 18. NLRP3 pathway becomes particularly important in obesity, metabolic syndrome, diabetes, Alzheimer's, and non-alcoholic fatty liver disease. All these are together, and this pathway has been studied a lot for this kind of chronic inflammation, making it a high priority pharmacological target in the aging medicine. And we'll allude this later on a bit more. Another very important part in modern science era, as we all understand, the gut microbiome plays a major role in regulating immunity and inflammatory balance. About 70% of our immunity stays in the gut. Very important organ, mostly ignored for some reason or the other. With aging and chronic metabolic stress, two major things happen in the gut. Microbial diversity often declines, which, if you see here, decreased lactobacillus, increased proteobacteria, reduced butyrate production, and then also it causes is the gut barrier integrity weakens. So that slowly leaks out to stuff like bacterial lipopolysaccharides. It enters circulation, and this is what we call metabolic endotoxemia. The term might you hear metabolic endotoxemia. The immune system interprets these molecules as danger signals now, resulting in the chronic immune activation. And gut dysfunction therefore becomes another important contributor to inflammation. Immunosense, we discussed that before, but while all other changes are happening in different organs, we discussed the gut, the cellular senescence, mitochondria. What is happening to our immune system itself? As the immune system ages, regulations become less efficient. And because innate inflammatory signaling often becomes chronically activated with different ongoing processes in the body, adaptive immunity weakens. At the same time, repair and resolution pathways become impaired. Does this mean inflammatory signaling may persist longer after stress or injury? The result is that reduced resilience and increased chronic low-grade inflammation. This process is referred to as immunosenescence and is considered as one of the central contributors to the inflammation. We see that two major concept messages from modern medicine information now we can recap now. One is the many chronic diseases are there, which we listed here also in this slide. Okay, they may not be biologically separate processes. Instead, they may represent a different downstream manifestation of a shared inflammatory mechanism. Inflammaging itself is not one isolated pathway. We saw that before too. It's a self-reinforcing network involving metabolism, immunity, mitochondria, gut biology, cellular senescence, oxidative stress, and impaired repair system and immune system. Now, each dysfunctional pathway now amplifies the other. That's why it becomes a chronic loop. This system biology framework is central to neuroscience and longevity medicine. That's where we want to work on. Researchers increasingly recognize that chronic inflammation contributes to cardiovascular disease, insulin resistance, obesity, neurodegenerative conditions like Alzheimer's, Parkinson's, autoimmune conditions, chronic pain syndromes, liver disease, and many other metabolic functions. Although these diseases affect different organs, they often involve similar inflammatory mediators and immune pathways. This is why chronic inflammation is increasingly viewed as a common denominator across aging related diseases. Now, let's talk about we're going through the inflammation as a common denominator. Like we concluded, despite the diversity of chronic disease, many share remarkably similar inflammatory mediators. These pro-inflammatory cytokines are molecular language of the inflammation. These cytokines act as biomarkers and also the effector of the tissue damage. We can measure them, but they also one who are causing a damage. Most common cytokines such as interleukin 6, TNF, ILIB, and CRP, they repeatedly come across all the diseases like cardiovascular disease. Now we know that CRP is often we can high sensitive CRP is very well seen for people for risk of cardiovascular disease. Again, metabolic syndromes and all other diseases I talked about, autoimmune, they all work with that. And these mediators influence endothelial function. They can influence insulin signaling. They can influence oxidative stress, mitochondrial health, immune regulation, and tissue repair. So they are again a effector and also the tissue damage and biomarkers. Many other inflammatory biomarkers such as CRP, ferritin, fibrinogen often rise, and we'll talk about that in a second also. Importantly here is that chronic exposure to these inflammatory signals may gradually shift the physiology towards dysfunction and accelerated aging. That's the basics of the longevity medicine. We know that Werko back in 1858 proposed that chronic inflammation played an important role in development of atherosclerosis. Today, we fully understand that the chronic inflammation is a driving disease in the cardiovascular health. And atherosclerosis is no longer viewed simply as a cholesterol accumulation. It is there, but it's recognized as a chronic inflammatory vascular disorder. That's what the atherosclerosis is, a chronic inflammatory vascular disorder involving endothelial dysfunction, oxidative stress, cytokine signaling, immune activation, and plaque instability. We know that LDL itself is not a problem, it's the oxidation, it's the inflammation that's happening, LDL, that's the problem here. Similarly, as we saw in the previous slide, that chronic inflammation contributes directly to insulin resistance and metabolic dysfunction. Now, if you see visceral adiposity, hyperglycemia, metabolic overload continuously stimulate inflammatory pathways, creating a self-reinforcing cycle between metabolism and immune activation. This is why metabolic disease and cardiovascular disease are deeply interconnected. Now, brain is particularly vulnerable to chronic inflammatory stress also. Neuroinflammation is being reviewed as being again and again looked for, as a part of the reason for a cognitive decline in Alzheimer's disease or depression and Parkinson's disease and other neurodegenerative conditions. Chronic activation of microglia, which is actually the cells, which are the immune cells of the brain. Okay, they can contribute to oxidative stress, mitochondrial dysfunction, cytokine release, and neuronal injury. Same process starts here. Inflammatory signal may also interact with abnormal protein aggregation and vascular dysfunction. This is one reason researchers now increasingly describe neurodegenerative as partly inflammatory in nature. The same way autoimmune disease and chronic pain condition, they share same chronic inflammatory mechanism. Persistent immune activation leads to inflammatory cytokines which contribute to tissue injury, pain sensitization, oxidative stress, and the impaired recovery. Now, the important part here is that not only chronic inflammation does these things, it also alters the nervous system signaling in itself, so which contributes to persistent pain and fatigue syndrome. This demonstrates how inflammation can affect not only structural tissue but also neuroregulation and sensory processing. Now, if you see inflammaging intersection, elevated systemic inflammatory tone, it lowers the pain threshold. So people feel more pain with autoimmune disease also. It impairs immune regulation and accelerates joint and connective tissue degradation in the aging patient. Very important topic here. NAFLD, which is a liver inflammation, also called hepatic part of the what we call as a meta-inflammation, which is the metabolic inflammation. That it is most prevalent liver condition affecting about 25% of the adults globally. As a recent fact, I was reading only yesterday, the World Global Health Organization actually named this as a condition to be much more sought. So family practitioners throughout the world will be looking more for this kind of condition now because this is really steatosis has been said that this is actually a precursor for cirrhosis. So look for this more closely. Metabolic overload and chronic overnutrition strongly activate inflammatory pathways. Visceral adiposity tissue that releases cytokines and inflammatory mediator. We went over all this, which causes insulin resistance, fatty liver disease. The liver becomes particularly vulnerable here because it continuously processes nutrients, toxins, inflammatory molecules, and gut-derived enterotoxins. This helps explain why obesity, fatty liver disease, metabolic syndrome, and chronic inflammation are closely linked. Very important. All these are linked now. The progression from the steatosis or NFLD goes to NASH, and fibrosis starts. Again, all inflammation happening here, and eventually become chronic cirrhosis. So, or end-stage liver cancer. That can happen here too. Now, over time, chronic inflammation does not simply increase disease risk, but it may actually accelerate the biologic aging itself. So it contributes to the damage, but also accelerates biological aging. Persistent inflammatory signaling contribute to mitochondrial dysfunction also, again, cellular senescence, frailty, and immune aging, and reduced resilience. This is why inflammaging has now become a central concept in neuroscience. Inflammation is this is the end of this section, so I'm going to give you this part, that inflammation is increasingly viewed as a biological bridge between aging and chronic disease. The major message of this section, like I said, is chronic inflammation is not confined to one organ system or one specialty. It represents a shared biological network influencing metabolism, which is also affecting vascular function, brain health, immune signaling, tissue repair, and aging biology simultaneously. This multidisciplinary framework is one reason why longevity medicine increasingly focuses on identifying and reducing inflammatory burden before irreversible dysfunction develops. The future of medicine may evolve in managing inflammatory trajectory as carefully as we are currently managing blood pressure or glucose. Now, let's go next section. Here's the meta-inflammation. Yes. One of the major advances in inflammation biology was the recognition that the chronic nutrient itself can be inflammatory trigger also. This led to the concept of meta-inflammation. This is again a chronic low-grade inflammatory state driven by metabolic overload and overnutrition. Unlike acute inflammation caused by infection or injury, meta-inflammation develops gradually through chronic excess energy intake, visceral adiposity, hyperglycemia, physical inactivity, and metabolic stress. All these are modifiable factors by lifestyle modifications. Now, in the Nature Review Endocrinology, if you see again, this study came in and shows that meta-inflammation shows that many mechanisms with inflammation like oxidative stress, mitochondrial dysfunction, immune activation, cytokine signaling, and chronic low-grade inflammation. This concept fundamentally changed how obesity and metabolic disease are understood now. The clinical implications of meta-inflammation are enormous, this was done by Dr. Gökhan Hotamuşlu. It's a Turkish scientist in 2006. He came up with that. This is This is named Houghton Mischke. That he actually in 2006 came with that. So this concept of meta-inflammation, reducing chronic inflammatory burden may improve not only metabolic health but also vascular health, mitochondrial resilience, energy production, recovery capacity, and healthy aging. Again, by lifestyle modification, we can work on all these things. This is why longevity medicine increasingly focuses on visceral fat reduction, insulin sensitivity, muscle preservation, sleep optimization, nutrition quality, physical activity, and strength regulation. The goal is not simply weight loss in a patient who's obese. The goal is restoring metabolic and inflammatory resilience before irreversible dysfunction develops. Adipose tissue is no longer viewed as a passive energy storage organ. We talked about that. Visceral adipose tissue is metabolically active and highly inflammatory. As adipocytes enlarge and become dysfunctional, immune cells such as macrophages infiltrate adipose tissue and begin producing inflammatory cytokines. This include all these cytokines that are listed here. Now, this is one reason why visceral adiposis is much more strongly associated with chronic disease risk than subcutaneous fat. Visceral adipose is more dangerous subcutaneous fat. Insulin resistance, if you see, same way. And in addition to meta-inflammation, we've been discussing chronic inflammation directly interferes with insulin signaling pathways. Inflammatory cytokines such as tumor factor, alpha, and the IL-6, they impair insulin receptors also, signaling and reduce the glucose uptake and promoting hyperinsulinemia. This creates a vicious cycle. Inflammation worsens with insulin resistance, and insulin resistance further amplifies inflammation. So it becomes a vicious cycle here. Type 2 diabetes actually is also increasingly recognized both as a metabolic and inflammatory disease. Chronic inflammation not only contributes to insulin resistance but also to pancreatic beta cell stress and dysfunction, which also causes problem. Again, this is NLRP3 activated pathway. Inflammatory mediators impair glucose regulation. They damage vascular tissue and promote oxidative stress. The metabolic and inflammatory systems are deeply interconnected. Let's talk about how we talked about inflammation, how can we measure it? Now, the patients may appear relatively healthy, while inflammatory signals, metabolic dysfunction, oxidative stress, all that is happening under the surface. This is why biomarkers become critically important in longevity medicine. The goal is not simply diagnosing late stage disease, the goal is to identify the biological dysfunction earlier and before irreversible damage develops. So inflammatory biomarkers now allow clinicians to track patterns of low-grade inflammation, metabolic stress, oxidative burden, vascular risk, and aging biology over time. Several traditional biomarkers actually are extremely useful, and we talked about sed rate, CRP, ferritin, fibrinogen, and fibrinogen is for coagulation disorders. Ferritin is very important for as an inflammatory stress marker. For the cardiovascular health, we have HRCRP, uric acid again for gout through this same pathway. Now, importantly, no single biomarker fully defines the inflammation. Rather, clinicians interpret patterns across multiple systems longitudinally. This is a very important part. Now, inflammaging and metabolic dysfunctions are deeply interconnected. Advanced inflammatory signaling tests may provide additional insight into chronic immune activation. We all understand that A1C provides hemoglobin A1C provides a long-term picture of glycemic exposure, 8 to 12 weeks. Fasting insulin HOMA-IR, HOMA-IR, which actually can identify insulin resistance before glucose becomes severely abnormal. Now, it provides a snapshot of the current insulin sensitivity. And we can talk about the calculation. We can multiply fasting insulin with the fasting glucose and divide that by 22.5. That gives you a HOMA. And if there's more than 1.5, it tells you there's an insulin resistance syndrome happening. So a lot of new biomarkers are coming in. Now, I know in America, AHA has just added ApoB and Lipo-A as a current guidelines with a lipid screening. So all the GGT is very important for the liver health, and actually it can diagnose the conditions before even the liver disease even develops. GGT can go bad before that. So these markers provide additional context when evaluating overall inflammatory metabolic resilience. One of the most exciting developments in longevity medicine is the emergence of biological age assessment technologies. I'm not going to go in detail in this, but just remember there are a lot of stuff that's happening in conjunction. We have a clinical presentation, then we have the biomarkers, and then these technologies like DNA methylation, see how fast you're aging, glycomics, metabolomics, and lipidomics. All these technologies may eventually allow clinicians to detect accelerated aging biology years before overt disease becomes clinically apparent. So still, although still evolving, these tools represent the future of precision longevity medicine. Longevity medicine emphasizes longitudinal tracking rather than isolated snapshots. One laboratory value rarely tells the entire story. We know that. We learned that in medical school all along. Instead, clinicians should increasingly evaluate trajectories. Is inflammation rising or improving? Is metabolic flexibility worsening? Is recovery capacity declining? In our clinical practice, I think Dr. Dunn is there also, but we do inflammation across 10 domains we have created, and then we see the patient actually gives us a score 1 to 5, and we see clinically how they're doing. Then of course we do a testing and we find out where they're going. So we put a whole trajectory together, and then we go from there. Is recovery capacity declining or not? Biomarkers become much more meaningful when they integrated variable data. Also, like our patients, we have connected them to our app, so we know the sleep hours, their heart rate variability, body composition, including their fat, visceral fat, muscle mass, water, cardiovascular fitness, and functional assessments, all, and like walking tests, sit to stand, all these things are done together. They all become one context and give us how to evaluate the information part. This creates a much more dynamic view of biological resilience and aging trajectory. The One of the most important implications of inflammaging to research is the biological dysfunction may begin decades before overt disease actually become clinically obvious. This creates an opportunity also for us. If clinicians can identify inflammatory burden, measure them through the biomarkers, and follow clinically patients, we can have early intervention more effective before irreversible damage accumulates. This is why longevity medicine increasingly emphasizes preventive care, longitudinal tracking, immune metabolic assessment, and lifestyle architecture. Very important by lifestyle modification. There's a American College of Lifestyle Modification. There's a British Society of Lifestyle Modification. All these are coming up now. The residency programs are now being they are introduced this curriculum, and there's studies now. The goal becomes preserving function here rather than reacting to the failure. Little different approach. We understand nutrition profoundly influences inflammatory signaling and metabolic health. Our diet affects insulin sensitivity, oxidative stress, endothelial function, gut microbiota. Very important. Anti-inflammatory nutrition generally emphasizes like whole food, dietary fiber, rich plant foods, adequate protein. By the way, there's now studies showing plant proteins could be equally or more effective than animal protein. Healthy fats, short chain fatty acids, and omega-3 fatty acids, polyphenols, and stable glycemic regulation is important. In contrast, now, ultra processed foods or chronic calorie access or refined carbohydrates and excess sugar contribute to metabolic stress and inflammatory signaling. Importantly, nutrition influences inflammation not only through calories but also through hormonal, metabolic, mitochondrial, and immune pathways. We learned that before also. Now, exercise, physical activity is one of the most powerful anti-inflammatory interventions available also. Exercise improves insulin sensitivity, mitochondrial function, endothelial function, glucose regulation, and inflammatory balance. A recent study in Lancet came in 26 January suggested that 5 minutes of extra walking a day can prevent 10% early deaths. Another study I saw showing just 5 minutes of strengthening exercise, resistance training exercise a day can be very helpful, positive. What happens is skeletal muscle is increasingly recognized as a longevity organ now because it produces myokines, which are signaling molecules that influence metabolism, immunity, and inflammation. But resistance training is particularly important because muscle preservation strongly influences aging resilience, metabolic flexibility, and failure prevention. In Australian 4-week study, I read, showed that physical and mental health is much better with 5 minutes of resistance training I was mentioning. It's an Australian study actually. So regular physical activity also reduces visceral adiposity, which is again one of the major drivers for the inflammation. Sleep, stress, and circadian. We can't underscore that, underestimate that. Sleep is one of the most underappreciated part, but it also has, chronic sleep disruption, chronic psychological stress increases cortisol dysregulation, inflammatory cytokines, insulin resistance, and oxidative stress and autoimmune balance. If you fix someone's diet, to fix their gut, to fix their metabolism, and you did not fix your chronic sleep issues or chronic psychological stress, you will not be successful in getting information out. This is a given thing. As we all know, sleep also supports lymphatic clearance, which is basically a sewage system for the brain during sleep, tissue repair, hormonal regulation, and mitochondrial recovery and immune function. From a longevity medicine perspective, sleep is not a passive rest. It's an active biological repair process essential for inflammatory regulation and resilience. Chronic stress strongly influences inflammaging also. One time, over load, the cumulative biological wear and tear associated with chronic stress, and that requires more demand and more causes more strain and inflammation. Longevity medicine increasingly emphasizes stress resilience and autonomic recovery through sleep optimization, recovery practices, meditation, breath work, heart rate variable monitoring, and we do that through the variable data. Again, mindfulness, social connections, very important social connection, nervous system regulation. All this happens hand in hand when you try treating a patient for the inflammation. The future of longevity medicine will likely involve much more precise inflammatory and biological age tracking. Advances in AI, wearable technology, and omics, sciences and system biology may eventually allow a clinician to continuously monitor inflammatory trajectory and biological resilience in real time. But rather than waiting for disease to appear, medicine may increasingly focus on detecting an early biological instability and intervening before irreversible dysfunction develops. The major message of longevity medicine is that chronic inflammatory burden is modifiable. And through longitudinal tracking and systems based interventions, clinicians can now influence metabolic health, inflammatory balance, resilience, and functional aging trajectory. This requires ongoing assessment. We discussed that. The ultimate goal is not simply extending lifespan, it's preserving biological function, recovery capacity, cognition, mobility, and resilience over decades. Medicine is really entering a new phase, and for decades, conventional medicine has focused heavily on managing disease through markers such as blood pressure, glucose, and cholesterol. However, longevity medicine increasingly expanding its focus toward biological resilience and inflammatory trajectory. Very different ways. In many ways, actually, chronic inflammatory burden may eventually become as clinically important as blood pressure, glucose management is today. The future, and this is future longevity medicine, is very likely to be in these terms, and it is very personalized and data driven also. With this, I want to close. I think we're a little over time. Thank you very much for listening to this. I'll take any questions if you have.
Thank you so much, Dr. Harsharan. Indeed, I'm pretty sure it has been a thoroughly informative webinar. I've asked everyone that if in case you have questions, you can raise your hand. So the raise hand option is on the react button. Dr. Harsharan, maybe you can stop sharing the screen so that I can bring the people online. And I would also advise the participants to switch on their videos while asking questions. It looks good when you are asking questions, and I don't want to talk to a screen. Yes, Mr. Tatarao, you have a question. So you may please unmute and ask your question. Yes, please.
Yes, sir. Sir, I'm W.T. Rao. There is a certain enzymes are there. In what are the role in delaying the aging process? And sometimes there is a cellular confusion leads to the identity loss. How to restore the cellular memory?
Ms. Vance, can you repeat what you said?
How can you restore the cellular memory is what you said?
Yes, actually there is sections are there which slow up the aging process, and sometimes there is a cellular confusion leads to the aging process, identity loss. How to restore the cellular memory?
Did you get the
Two
question?
questions are there. Two questions. One is the role of search engines and second
What is
is
the
the
role of, could you repeat?
searchants. SUR searchants. One
Uh,
enzyme is there, it is preparing the DNA, all these things, and how to
uh,
reverse the slope the aging process.
One is, how do you stop the aging process, is what you're asking,
Slow
right?
slope the aging process, and
Slow
second
down.
is the cellular confusion is there. In that, how you restore the cellular memory.
When there's a cellular confusion, how
Both,
do you restore the
both
cellular
are
memory
related to aging process.
through the aging process? Okay.
Okay. From the aging perspective, if I understand your question, the aging perspective is that we can slow down the aging by getting inflammation down. And this is a very important question actually, because if you see, I said the aging itself causes inflammation to an extent in every organ, and that inflammation actually accelerates the biological aging. So our one of the things we do in clinical practice is we tell our patients that your biological age, we got to bring less than chronological age. It's called anti-aging. So the way we do it, all these optimizations we talked about, the sleep, the stress, getting information down through all these things, we have 10 domains we have created, and then we get the metabolism better. If needed, we give them some peptides. If needed, we give them right kind of vitamins as antioxidants and anti-inflammatory. And then also we give them, make sure they do physical activity right. All these 10 domains are done, and then slowly the inflammation starts going down. That will slow down their aging process because it will cut down the inflammation. Now, important part here is that people say, like, I'm 57 and my metabolic age is 46, because I actually go back and do my rules that I teach, and now I can slow down my aging process like that. That I can do these parameters, I can do cut down the inflammation, and that's how we can do it. Did I answer your question?
Yes, sir. Yes, sir. Thank you.
Okay. Okay.
Thank you. And if you have any question, you can also type it on the chat box if in case that's something has been missed. Okay. Sharmila, you have a question. Let me bring you on the screen. Yes, please.
Hello.
Yes, we
Hi.
can hear you.
Hello. Good morning, Dr. Singh. So I'm
Good
a
morning.
pediatrician. I'm a practicing pediatrician. So I understand this longevity mostly concentrates on the older adults, but I feel that since the onset of the chronic illnesses are starting much earlier, even in India, and because of all the lifestyle changes happening in the last few decades, and even the kids' diet, obesity, so everything I'm saying, the onset is much earlier. So I feel it has to start from the pediatric age group. So what would be your suggestion? I mean, how to integrate all this into pediatric practice? Is it even possible, or is it even advisable?
Actually, very good question. I'm glad because I think I tried to say that in a subtle way, but you brought it up. This point very important. If one of the slides did show that you start the age at 30 or 20, but now we're seeing a lot of pediatric obesity. We're seeing diabetes at early age, and this is all coming
Yes,
from
sir.
the processed food or sedentary lifestyle. That's why I again mentioned this thing, that the process here is not to wait for this to happen and then treat it.
Correct.
Process start early. So you're doing the right thing by, okay, I want to start now. Now,
Mm.
many patients we actually have, they are not even sick. They are just regular 20, 30-year
Mm.
old people, but they want to develop a habit now so they don't get
Mm.
sick when they are 60 or 70 or 80. Like I said, the
Yes, sir.
centurions are going up now because that's what they're saying. People will be 4 million people by 2050 will be living
Mm.
more than 100. So the process has to start early. So they're definitely fully advisable. Number one. Number two, same thing happens to if you can, your child to same thing. Hey, don't eat this and remains physically active. And muscle mass is important. Sleep is very important. I know you probably are Hindu, right? In our
Yes, sir.
in our religious all the time, Christianity, every religion we see, it's already said that get up in the morning, take your
Yes.
time, do your prayers, then
Yeah,
stay cool.
mindfulness.
Mind, yes, all that. And then, eat right thing. And by the way, fasting is also advised. All these things
True.
are very good. And I actually feel very honored about the fact that the Eastern community, when I was growing up as a child, I learned these things and I know these are the actual rules. We, with the modern life now, we've forgotten. We have just gotten lazy and gotten more, but we need to go back and has to start as a child.
Mm. Yes.
Like adequate protein intake is very important, just to let you know, for children also.
Yes,
I
sir.
hope I answered your
Sure.
question.
Yeah, yeah. Thank you. Yes.
Okay.
Thank you. Thank you, Dr. Shamila.
Thank you.
Nice question there. Yes, Ram Singh, you have a question. Please ask your question. You're not able to unmute. Yeah. Yes, please.
Good evening to all. My
Very good
basic
evening.
question is that how close the functional medicine is to longevity medicine? And second, Honorable Dr. Harchan Singh ji, which are the top 3 or 5 nutrients or the supplements according to you, which are top required for the healthier and long living? Top 3 supplements or the nutrients, and how close the longevity medicine is with the functional medicine. Thank you.
Okay, so let me answer your first question. This one, longevity and functional medicine. Okay, and again, there's no division as such, but I have created this definition. First, there's a conventional medicine, and there's a functional medicine that's going on for a long time. Again, it's a whole body approach, like longevity medicine. But functional medicine also doesn't go back into these details of variable data and the biomarkers and all these things to go to ease the early dysfunction, early kind of signaling before it becomes a permanent pathology. So that's the difference I see between functional medicine and this one. But on the other hand, they both are very much alike. But difference is longevity is much more detailed, and we always look for new name, and longevity is a kind of evolution of functional medicine, if I could say that. Okay, that's one. Now, coming back to my typical recommendation I tell people is if you can get a pharmaceutical grade multivitamin, because what happens is our vitamins that mostly we're getting, either they are food grade or they don't have enough kind of nutrients in them. But along with the multivitamin, make sure you have a probiotic and an omega-3 as an anti-inflammatory. The dose of omega-3 should be 1,000 milligram. Now, the study showed if it is more than 1,500, it could actually cause some cognitive decline. But that is a very questionable thing. This just recently came in. But omega-3, 1,000 milligram is good anti-inflammatory. But as far as the particular components of the multivitamins, if you're asking, this is very subjective. We check like magnesium, zinc, all these levels, depending on what is deficient. But you definitely, like, I'm vegetarian, so vitamin B12 is good for me to have it. But if you're getting a good multivitamin, we have male and female separately. Then we have female with, I was just talking to Miss Baines earlier that Vita One has very good products actually. So I looked at them, and thyroid supplement, processed supplement, all these things come in. So depending on your need, but a multivitamin, a good one with probiotic and omega-3. These are the basics I gave. And by the way, one very thing just to mention, there's something called gut-brain axis. We didn't include that in here, but that's very important. So someone is having a lot of stress, and I've seen a lot of patients now, they come with a lot of stress, and they don't even mention about GI. And when I talk to them in detail, because we have 10 domains, it comes up there. So when I talk about, oh, I get a lot of bloating, or I get a lot of, gas, constipation. So once you fix that, their stress gets better. I had a patient, actually very nice, just to mention. Is Dr. Dunn still there? I know she saw that with me, but we had a
Let me check.
yeah. So then she had a lot of stress issues, even ticks like neck ticks and all that, and we fixed her gut mostly, and it helped her. So if you go to all details and go biomarkers and all that, you can actually go to detail and find out what is needed. I hope I answered your question.
Thank you, sir. Thank you.
Thank you.
Thank you. Thank you. Nice question there. Very much needed. And of course, therapeutic grade, which are biologically available, becomes a very important need for supplements. I'm going to go to the next question. Just give me a minute. Yes, Ramana Rao, your question, please. Just hold on. Let me help you unmute. Yes, please. Yes.
Namaskar, sir.
Namaskar.
Namaskar.
Sir, there was a news item that Mr. Vladimir Putin, sir, he had instituted one research on the longevity. He wanted to live for another minimum 100 years. Do you have any knowledge about that, sir? What are the various things which he has been instituted?
So your question to me is, Vladimir Putin had some article or something you wrote down, how to live 100?
Yes, sir. He has instituted some research, in fact, to his scientists regarding that.
With all respect, I'll read a medical journal. to what how to live 100, and I just told you all the how to live 100. And I tell you, mine is really science backed, so I don't know what to say about him. I have not read that article though. But if you want to tell everyone what it is, then maybe we can discuss that.
Since I don't have any knowledge about that, I'm just asking, sir, whether you have
No,
anything.
I tell you, if I see a source coming from a, politician or something else, now, by the way, this is you brought it up. You will see a great actor or someone showing that, okay, how to do hair right, okay, or female actress how to hair. That doesn't mean they know about hair. It's just they're being paid to do something. Okay, but
Yeah.
what we discussed today is a science.
Yes, sir. No,
But
scientifically,
if I mean, you look like you're doing good. I don't know how old you are, but you look good in health and all that. But if you keep doing these things, cut down inflammation, eat diet, keep your physical activity, get your muscles up, and watch everything we talked about, you'll live 100.
yeah, I am 68.
There you go.
I am a homeopath from Bangalore, sir.
Okay, all right, very good. Yes, I respect. I miss and in here I miss that homeopath and the
Ayurvedic.
Ayurveda. Yes, I remember a lot of my friends, they went to different areas. I went to allopathic, but I love the how. And by the way, one thing I say, when I
Sir,
talk to these patients now through longevity medicine, Ms. Baines, I talk to them like homeopathy talks to them. Like we go through full history for an hour and a half. What you like, cold or you like hot, or you like, because these are important things. In our allopathic medicine, we don't have that detail.
fine,
And the
sir.
time.
So
Thank you, sir.
Thank you. Thank you. Nice, interesting question. No doubt. Lot of things going on in the name of longevity. I do understand, Dr. Harsuran, do you have
Yes,
how many minutes do you have?
I
I
can
can
take one more
understand.
question if you don't
We'll
mind.
take
I have to
one
leave
more
one.
question.
Yeah,
Okay, I'll
yeah.
take Dinesh's question then, because Sir has to leave. It's a morning there. I'm just gonna take Dinesh, you have a question. Please ask your question. Please ask your question, Dinesh. I am not able to unmute you. So I don't know. We are not able to hear you. Yes. Yes, please.
I see him now.
Mr. Dinesh, I think the internet at your end. Yes,
Good
please.
morning. Good morning, sir.
Good morning.
My question is, after Corona, cases of food intolerances have increased, which affects our immune system, but it is not being recognized by the doctor. Like in my case, after Corona, my KIPS value, liver stiffness has gone to 16.8 in cirrhotic range. Then I got my food intolerance done. I wanted to eat male.
Should I ask him to type the question? That would be better.
Yeah, because
Certain foods,
I
so
missed them.
I left all those, and my value came down to 9.4 without any.
Just 1 minute. Just 1 minute. Dinesh ji, could you please type in your question? Your internet is not stable. We are not able to understand your question. Please type in your question. I would highly appreciate that. I'm just gonna, Parveen, you have a question. Very quickly ask your question, please. Parveen.
Hello, sir. It was a
Yes.
fantastic presentation, and the slides were really good. And wanted to ask you, what is
We can't hear you. Parveen, repeat. Please repeat.
yeah, how to calculate the metabolic age and the correct age of the person? Like the sir has told, no, he is 57, but his metabolic age is 46. So I wanted to
Yeah.
know how to calculate this. Thank you.
Okay. Okay.
Thank
Very
you.
good question. Okay. So biological age or metabolic age is different from chronological age is number of years you've lived, right? Or a calendar time, a timeline. Biological age actually is the one which tells you what your functionality is, how good you are at the cellular level. So the way we calculate, there's no actual formula as such for it. We do is different, and there's a inbuilt formula where we put different. Like I could do this with just with like four parameters. Like we have a scale that will tell us if this person's weight is this much, and muscle mass is this much, fat is this much. It will give you its output. Okay, the metabolic age is this. Same way, so we can do the formula, like we do all the blood work, like biomarkers, there are about 100 of those. We put that in the system and it spells out a biological age. There's no simple formula that divide, multiply by this. No, it's a combination. And by the way, there are two kind of biological age also we call it. One is a body composition biological age. How bad, like I have patients who are, they're not overweight much and they're from body composition point of view, their biological age is same, almost same as a chronological age. But on the other hand, if the functionality is not good, they have no energy, or they have low libido, or they are losing hair, or they have other issues, then their functionality shows a higher biological age than chronological age. So different formulas in there. I don't think there's a formula that I know out there which is simply says, okay, multiply by this with this and we'll get by. No, there's not like that.
Okay,
And
sir.
one thing more I said, by the way, one thing more I just said earlier, and we never look at one time age. My goal is to get that biological age calculated and then go towards chronological age as much as I can and bring it lower than what they was so that I can. So basically, what we're doing is not actually decreasing years. We are decreasing make sure the pace of aging is slowed down so that their functionality is better and they are slowing down in your aging process in the future.
Okay. Thank you so much, sir.
All right.
Thank you so much,
Thank
sir.
you.
And of course, I know it's time up. We'll not be taking any further questions.